Hello everyone, today is March 6th and I have to apologize. I was not able to get the liquid nitrogen today to do the superconductor video. That's okay, we're going to make up for it with discussion of magnetism. There seems to be a lot of misunderstanding of electromagnetism, and I want to give a shout out to two people. First, to Stenti. And if you haven't seen his paper, if you haven't read his paper, New Electromagnetism, which published probably more than 30 years ago, there is a link at the Electric Universe Gateway. And also, I want to say that I think that Dr. Scott's work is really good. This video is for a certain person out there who is having a bit of a hard time right now. I don't know what he's going through. But certainly one has to watch out for poisons such as anger and frustration, and certainly try to be cool and calm about everything. But we're all going through something. I mean, for instance, I've got all this taxes and house stuff going on. I got to go and look at a house later, so it's a trying time. I find that after a day like yesterday, there can be several blockages. I was at an intersection, and a fire engine was going this way, and an ambulance came this way, and another one, and it went that direction, and then another one came down and went the other direction. It all happened at the same time in the same intersection. Then I was on the way here, and somebody jumped in front and tried to get me to T-bone them, so I was able to hit the brakes there and prevent that. But everybody has potential blockages and things that could come up, and we just have to be as supportive as we can through those tough times, whatever that person is going through on the inside. So let's talk about magnetism. Magnetism is different than electricity. I mean, they are one force, and that there is an interrelationship between them that was described by Maxwell's equations, which were then simplified by Heaviside. And those equations, we still call them Maxwell's equations, define a relationship that exists between them that is most exemplified by light. Now, let's talk about light for a second. I want to make this absolutely clear. Light is not a particle. We model it as a photon, which has no mass, because it's convenient to model it as a photon, but we don't actually have a good way of modeling it. Now, Ken Wheeler, the so-called angry photographer, Theosophia, whatever his username is, he has claims that he's written the book on magnetism. Yeah, if you can get through it, it is a disaster as far as editing is concerned. But it does have a lot of diagrams. And his point, which I concur, is this is probably the closest to saying what light is that it is the rate of induction through a field, and that field being disturbed, Stenti calls the ether. There are plenty of ethereal models that still are out there, whether they're space-time or dark energy, strings. There are all sorts of ether models out and about, and ether model is alive and well because we have been unable to identify the source of what would keep an atom going, what would keep the world spinning. If everything is going to a higher state of entropy, then what is actually keeping things going? And it's obvious that the universe is infinitely aged. There was no origin like a Big Bang, because mathematically it makes no sense. You're saying something's coming from nothing, and then you're saying it's going to cease to be, and the stars are going to cool for 100 trillion years, and then what? So it has no, there's no conservation of energy there, there's no conservation of mass there, and it violates the laws of thermodynamics. And for the 5 laws of thermodynamics, I definitely recommend Sky Scholar channel. So when we talk about electromagnetism, we have to define the difference between electricity and magnetism. So in electricity, you have a point charge here and an opposite point charge here, so let's say positive and negative. A field will exist between them, and then a magnetic field will wrap in a perfect circle if there's no other influence, according to the right-hand rule. So if we have an electric field moving from here to here that would accelerate a particle along it, and then we have a magnetic field around it. Now, those magnetic fields are not lines, folks. They're not lines. When you see a bar magnet that's been laid out and then iron filings have been laid and then it makes some lines, you must understand those are areas of concentration of stronger field versus weaker field. But at no time is the field exactly zero, and at no time are there lines to break apart. There is always a continuous flow. There exists no actual unipole or monopole. You can generate one by arranging atoms in a certain direction, but in reality, every magnetic pole is always bipolar. There's always two ends to the magnet. If you break the magnet, you'll end up with now two sets of north and two sets of south. And those lines, those concentrations are going around all the way. So it's actually ovoid in shape. It's like an ellipse that's been rotated around. It is emanating in a field that degrades by the square. So if I have my neodymium magnet cube here, the field is out here. I don't feel it, but it's still there, and it's out here too, and it's out here, and it's continuous, and it increases in strength by the square until it gets within acting a distance of which it exceeds the typical strength that we're used to feeling, and then suddenly we feel it, and boom, there it goes. Right? And it accelerates, obviously, because forces accelerate. That's what a force is. A force is actually energy moving along a vector, but its definition in terms of mathematics and how we measure a force is, of course, mass times acceleration. So you know that there will be an acceleration if there's a force in presence because it's in the mathematical relationship. There's no time involved in that equation except in the acceleration. So the acceleration, then you use the acceleration, and you can integrate and get the velocity, and then you can from there know based on the distance how much time it's going to take. But in terms of the force is acting timelessly. It's always acting at all times, but it has to be going through this unknown ether. Now, some people, they want to call that dark energy. It's fine, but that's not what the scientific community means by dark energy. They mean something that's accelerating the universe away from a central point. That is not what's happening. There might be some expansion. We have no idea because nobody's created the models together yet using intrinsic redshift to look at the idea of old light and aging in the spectrum, in the redshift spectrum, to determine whether or not. But I suspect that some things will be expanding, some things will be contracting, and they will be rearranging at all times. And that's exactly what the Chinese scientists also say about the changes, is that they're continuously going in a cycle, and they will be moving from here to there, and as far as we can tell, there would be no end to it. So it's sort of like in one of those games where you're driving along, and there's a fog. You don't know, you haven't been through the fog yet. And once you get there, you know it's there, but you forgot what's behind you. And so, the sun is going to be moving through that, the Milky Way is going to be moving through that, Laniakea is going to be moving through that, and there's something beyond that. To pretend that we're the center, even by saying our universe is the center and that it exploded and it was born, is the fallacy of the ego. It's the fallacy of the human mind to not understand that, yeah, you're born and you die, but that is only this form. It's not actually your true self. It's not the true nature of who you are. And so we're projecting that onto our universe, like it's ours, that we invented it or discovered it even. We are just a small part of a large bit of mass that's moving through an infinitely sized thing. And people say, how can it be infinite? How could it not be infinite is the question. None of the equations indicate any practical reason why it would be limited. And you can't do math on infinity, so you can only do math within what you know. Now, as far as this idea of, that there are magnetic fields that can disconnect and reconnect, the only reconnection that's happening is the arrangement. So if you have a north and a south pole, they're already reconnected. If you have a north and a north pole, they're never going to reconnect because there's nothing to reconnect. By definition, the north pole is going to go to the south pole, and it's already happening inside the bar magnet and outside because that's what a circle is. There's nothing in a circle to reconnect. there is no actual flux happening. Unlike when you have a particle and it moves along the electric field, which has a definite start and a definite end, because there's a point charge and another point charge, or there's a gradient for high voltage and low voltage. Something is moving there. There's something to break. There is something to flow. There's a something. With magnetism, there is a nothing. Now, here's the other interesting thing. We don't have a good model for magnetism as well in terms of the law of conservation of energy. We have this idea that, well, these things will attract and then they reach static equilibrium when they touch. Sort of. Now, they're still exchanging energy back and forth because there's vibration happening on an atomic and molecular level. But then when we talk about the repulsion, we don't really have a good model for explaining how that's there and why it's going to be there. And superconductor, the whole point of the video I was going to make today was about how the model for superconductors is a little bit inaccurate. It doesn't seem to follow the laws of thermodynamics, and that you're going to have something that, so long as it remains at that temperature, has zero conductivity or resistivity, and even then, the fact of zero resistivity is a highly suspect idea. It probably indicates that we don't have a good model for magnetism as already. I've defined field somewhere else, I don't remember if it was one of these videos or an article somewhere, as a field in general, whether it's a chi field or magnetic field or an electric field, is a relationship. And a relationship between two things is going to generate that field. Now, if there's a frequency issue between them, it could generate a separation or repulsion or disresonance. And if there's an attraction or resonance in the frequencies, for example, the numbers 3, 6, and 9 have resonance, then you will create an affinity, and there will be sometimes a natural, sometimes an unnatural attraction between the two things. And both of them are perfectly natural and part of the everyday experience that is going on around you. You could have a natural attraction to soda, and that may not be that harmful to you, or you could have an unnatural attraction to sugars and soda, and that could be the death of you. And it really is completely dependent on the energy arrangement in whatever system you're defining, whether it's a friendship, a collegial relationship, a parent-child relationship, a spousal relationship, your job, a project you're working on. You might want to write a book, but because the energy arrangement for the circumstance is not right, perhaps it's not the right time, perhaps it's not the right subject, even though you're interested, you're unable to get it past this writer's block and put what you have in your heart on the page. It probably means you just need more refinement to work through it, because right now there is a magnetic repulsion. This is on a different level than with the neodymium magnet, but it works nevertheless, it works the same, because everything is one unified field. Is what I'm trying to tell you, that Tao, Qi, all the words that we use, electromagnetism, we talk about the weak force, the strong force, all of these do not get at the isness of what it is. When we draw magnetic field lines, we are just expressing a concept of, oh, it's in this direction. But it's not like that, because if there was a magnetic field line, if you put a steel bearing next to that bar magnet, it's going to go straight for the magnet. It's going to follow any lines. Those lines are nothing but concentration levels. They're like logarithmic lines, which again are not real either. That's a mathematical concept that we have created. When you try to look at the universe and define the isness of the situation, bear in mind that nothing's as what it seems. This shirt is not blue. If it's any color, it's every color but blue. It's just reflecting blue, and it's coming to you. And then secondly, you have to go, well, is that blue? Is that true blue, or is this more blue? Which one is it? And if you zoom in on that, which side of the frequency, up 1 hertz, down 1 hertz is more blue? And after all, it really is neither. It's empty. But we say in the sciences, and the secret sciences, and many of the sciences from around the world, that true emptiness is not truly empty. I want to remark one last time on the fact that everybody has their own ether or source story, And the irony is everybody thinks that they're more sciencey than everyone else, and that there is a general, like someone can have like say Neil deGrasse Tyson or Stephen Hawking can have the more authority on that experience. That is not true. Now, there are certainly people who are more superstitious, and there are certainly people who adhere more to the scientific method, but that doesn't follow that their version of ether is more science driven than other people's version of ether. Ether is undefined, it's unknowable. It's something that nobody's been able to find yet. And it says right in the Tao Te Ching that as soon as you name the Tao, you don't have it anymore. All the words that we use to try and get at this unified field really end up dividing things and making them more complicated. Models are good. Practical use is even better, such as here. The technology that is developed from such things can be good. It depends on the overall use and what's the outcome, and has it helped people or not, which is what science is supposed to do. However, that doesn't give anybody a stamp to say, well, I'm more right than you. Now, I know that I'm against flat earth theory, and I'm very, very unabashedly against it, because I primarily think, now, if I come across a person who really just is so ignorant that they don't understand how the round earth works and how heliocentricity works, I will patiently describe to them how that works. But most of the time, I think it's just people who need attention. And I'm very impatient with people who just want attention all the time. They should probably work on refinement. Speaking of which, everybody has something that they're going through and that they're working on. And we're all capable of finding faults with others and faults within ourselves. Number one, if we're finding a lot of faults in other people, probably better look inward. Number two, if we're overly hard on ourselves, probably need to learn to accept ourselves and to love ourselves and be patient. And if you want that kind of confidence in yourself, you probably have to step back from things, de-stress a little bit, let go of any radiation that's been coming in, or maybe it's tax season's getting to you, and all these things that are coming up, and improve the inner condition. And then when you go outward, it's easy to make the changes. It's easy to be the change you want to see in the world, and it's easy to change others because you changed yourself first. And that's my recommendation for the day. I hope you liked the discussion of magnetism and magnetic reconnection. If you like, then subscribe and share, and I hope to see you next time. I hope you liked the last video too, by the way.